All right, how's it going, everyone? Thanks for watching this video. Make sure, of course, you hit the like button under this video. That would be awesome. I would greatly appreciate that. Uh, this video, of course, is looking at adding and subtracting fractions with unlike or different denominators. Of course, as you see on your screen, we have our Common Core Standard, which is NC5NF1, which is the North Carolina Common Core Standard for 5th grade. The first portion looking at adding and subtracting fractions with unlike denominators. For a better understanding, I would suggest watching my previous video on adding and subtracting fractions with like denominators or the same denominators. It would definitely be helpful because that's going to bring us into this, which is a little bit more complex, but we can definitely still do it. Do take note that you can pause this video at any given time to copy down any information as well as solving some of the problems that you're going to see. All right, so let's definitely hop right into it. While I move this around a bit, I want to take note of this pretty cool app that I am using, or the website rather. It's called Braining Camp. I like this website because it has a lot of manipulatives that you're able to use. But yeah, definitely check it out. Again, so let's go ahead and take a look at a few problems and solve them together. Our first problem we're going to look at is adding these two fractions here, 1/2 plus 1/3. And what you may notice here, we have two different denominators, okay? Now, again, going back to my previous video, you need to have the same denominator to mathematically and properly solve any adding or subtracting problems with fractions. As you notice here, I have a fraction tile that's representing my one whole. I like to have that usually up because fractions are part of a whole. So I want to figure out, okay, well, if I have one fraction, which would be 1/2, and I want to add 1/3 to that to figure out how many I have, again, I need to have a common denominator. Now, on a side note, one thing you may hear from teachers or from videos is you can go ahead and multiply the two different denominators together and get one common answer, and that would be your common denominator. Now, that is 100% correct. However, I do have my idea, and it's not just my idea, but a few people find it useful. But I'm going to let you know a little bit on that later on in this video, so stay tuned as to why that is not my number one go-to source of doing that. But nonetheless, what you need to do is have a common denominator. So how do you do that? You may hear of finding something called the least common multiple, which would then give you your least common denominator, the LCD. Now, your least common multiple, what that means, you're going to list out your multiples. And multiples, of course, think of multiplication facts. It's like you're skip counting. So here I've put multiples of 2 and multiples of 3. And I just listed a few of them because they can go on for pretty much forever. And I want to find the least, the first one that they have in common with each other. Okay? So here, if I list my multiples of 2 and 3, I'm going to check to see. My multiples of 2 are 2, 4, 6, 8, 10. Again, I can go on forever, but I'm going to stop there. And then my multiples of 3 are 3, 6, 9, 12, 15. Again, I can continue going, but I want to find the first one that they have in common. Now, the first one that they do have in common, of course, is 6. So with that being said, that's going to now become my denominator, my common denominator. Now, the next step you have to ask yourself is, how do I get from 2 to 6? I need an equivalent fraction. An equivalent fraction is basically an equal fraction of a previous fraction that you have. So I need to find an equal fraction of 1/2 that has 6 as its denominator. So how can I get from 2 to 6? What can I multiply times 2 that will give me 6? The answer, of course, is 3. And I usually tell my students, what you do to the bottom, you do to the top. So I want to say also on a disclaimer, forgive my writing. It's a little bit hard using a mouse or a trackpad on a computer writing with this, but I'll make it work. So 2 times 3, of course, is 6, which at the bottom you do to the top. 1 times 3 is 3. So an equivalent fraction of 1/2 is 3/6. Okay, what can I multiply times 3 to get 6? The answer, of course, is 2. What you do to the bottom, you do to the top. 1 times 2 is 2. So now I have two fractions with the same denominator, and I can go ahead now and add them. Again, that's like saying I have 3/6. I'm going to add 2/6 to it. How many sixths do I have in total? Now, you do not add the denominators. Your answer is not 5/12. That is incorrect. You leave the denominators as they are. So my denominator is a 6. And you only add, mathematically speaking, you only add your numerators. 3 plus 2, of course, is 5. So your answer for this problem is 5/6. Now, what's cool about this, I'm going to show you on a number line as well. Let me put my pen back here. On the number line, I have it all set up for sixth, and I'm going to show you. I'm going to add a half. That's what we started with. I'll bring it down here so you can see. And notice, one fraction tile labeled a half is equivalent, and it ends at 3/6. So now you know 3/6 is equivalent to 1/2. If I add another fraction tile of a third, look to see where it ends. So these two together will give me 5/6. And that's our answer that we had there. Another great way of thinking about that is if I were to now think, okay, if these two fraction tiles together will give me 5/6, if I bring out my sixths, and that's 1/6 there. If I bring out 4 more for a total of 5, it should be equivalent from this end to this end. So let's see. 2, 3, 4, 5. So there we see 5 fraction tiles of 1/6 is equivalent to 1/2 fraction tile plus a 1/3 fraction tile. So 1/2 plus 1/3 equals 5/6. All right, let's try out another one. Here we have 1/2 plus 1/5. Again, two different denominators, so I have to find a common denominator between the two. So I list my multiples of 2, 2, 4, 6, 8, 10. Multiples of 5, 5, 10, 15, 20, 25. Again, I can go on forever, and I'm basically just skip counting, but I want to find the first one that they actually have in common. And the first one they have in common is 10. And you might say, well, Mr. O'Neal, can I multiply these two denominators? Sure, but that is not always my go-to source. And again, I'm going to explain that reasoning later on in this video, so stay tuned. So I get 10 as my denominator. So how do I get from 2 to 10? I need an equivalent fraction that is equivalent to 1/2. So 2 times what will give me 10? The answer is 5. 2 times 5. What you do to the bottom? You do to the top. My students usually repeat that after me when I say it in the classroom, so hopefully you're getting the hang of it and repeating it as well. 1 times 5, of course, is 5. So here, an equivalent fraction of 1/2 is 5/10. Same thing here. 5 times what will give me 10? Well, 5 times 2. What you do to the bottom, you do to the top. 1 times 2. And that, of course, is 2. So if I have 5/10 and I want to add 2 more tenths, put my plus sign there. The answer, which I will write here, of course, is 7/10. Remember, you keep your denominators the same because they are the same, so you just leave it, and you're only adding the numerators. So when you're adding or subtracting, denominators must be the same. All right, so let me put my marker here, and let me show you on the number line, again, which is really cool. So here I've set it up in tenths, and I'm going to take 1/2, bring it down here, and I'm going to add 1/5. And notice where it ends, where these two tiles stop, it stops at 7/10. So if I want to count tenths now, I'm going to bring up tenths here. 7 of these should equal these two tiles. So let's see, that's 1, 2, 3, 4, 5, 6, 7. So there you go, 7/10. Great. All right, now it's going to be your turn. I want you to go ahead and pause this video and practice these next two problems on your own. First, we have 1/4 plus 1/8. And I kind of started it off for you. I've listed the multiples on this side. And I want you to go ahead and remember you need the same denominator. So pause this video now and try to figure this out. All right, hopefully you were able to pause this video and come up with an answer. So let's go ahead and do it. Again, we need a common denominator. So if I list my multiples of 4, 4, 8, 12, 16, and again, I can keep going. List my multiples of 8, 8, 16, 24, 32. Again, I could keep going, but I'm going to stop because I already see that I have something in common. Actually, I can see I have two things in common. But remember, you want to find the least common or the first common one. And the first common multiple between 4 and 8 is 8. Well, Mr. O'Neill, I see that also there's 16. You're absolutely right. But remember, I'm going to explain everything in a few minutes. So I'm going to put here an 8, and here I'm going to put an 8. So now I have two of the same denominators. Now notice, here is an 8 as well. So if you were to think, well, what can I multiply times this to have an equivalent fraction? Well, the only way only number rather, you can multiply times 8 to get 8 is 1. And if you multiply the numerator times 1, you're going to get 1 as well. Another way of looking at it is you don't need to change this fraction because you already have what is common, what the denominator is between these two. So the only one you have to change now is this top fraction. How can I get from 4 to 8? What can I multiply times 4? You multiply 2. And what you do to the bottom, you do to the top. So 1 times 2 is 2. So here we have 2/8 plus 1/8. If I have 2/8 and I want to add one more eighth, you're going to have a total of, hopefully you got this answer, 3/8. That is the answer, 3/8. Now, check it out on the number line. Pretty cool. So again, I set it up in eighths, and now I'm going to have a fourth. Bring it down here. And I'm going to add 1/8, and I want to see where the two tiles end. And notice, it ends at 3/8. So if I were to say, well, what's equivalent? Well, here's another way of checking this out. If I put 1 there, that's 1/8, and I add another eighth, I have 2/8, which is equal to 1/2. It's sorry, not 1/2, 1/4. It's equivalent to 1/4. So if I were to add these two plus this one, I would end up getting 3/8. All right, last problem I want you to try out. It's a little tricky. Here is subtraction now. Remember, subtraction. So I want you to go ahead and subtract 1/3 minus 1/4. So pause this video now. Remember, list your multiples, find a common denominator. The first one that they have in common is going to be your denominator. So go ahead and pause this video now and see what you come up with. All right, hopefully you were able to go ahead and pause this video and come up with an answer. Now, I'm going to go ahead and list my multiples here for you, and hopefully you would have the same thing. So let's list our multiples of 3. We have 3, 6, 9, 12. What comes after that? 15. Good. Again, you're just skip counting. So I can stop there. Here is my multiples of 3. Now I want to list my multiples of 4. So we have 4, 8, 12. What's after that? Good. 16. Next. 20. Again, hopefully you're saying all of them and counting. That would be fantastic. There we go. All right, so now I can list this over here and put it here. Now remember, you want to find what is the first one that they have in common. And the answer, of course, is 12. Mr. O'Neill, couldn't I have just multiplied 3 times the 4? Yes, but again, that is not my number one thing to do. And again, I'm going to explain that right after this problem. So let's now put 12 as our common denominator. We have 12 here. We have 12 here. So again, what times 3 can give you 12? Well, the answer is 4. And what you do to the bottom, you do to the top. So 1 times 4, well, that looked a little horrible, but again, trackpads are a little tricky there. There we go. 1 times 4 is 4. And what times 4 can give you 12? You multiply down here, you get 4 times 3. What you do to the bottom, you do to the, good job, the top. Hopefully you're saying it at home or wherever you are. All right, 1 times, that looks a little silly there. 1 times 3 is 3. So now, remember, we're not adding. So if you got 7/12, you actually did it, you probably did it about 50-50. You set it up well, however, you forgot the operation. Remember, you're subtracting. It is not 7/12. That's only if you were adding. However, we are subtracting here. So if we were to subtract, 4 minus 3 is 1/12. And hopefully you got that as an answer. Now, let me show you on the number line again, which is really cool. So on the number line, I set it up in 12ths here. Let me go ahead and do that. Set it up in 12ths. And I have 1/3, which you can see is equivalent to 4/12. And I'm going to subtract now 1/4. Now, if I put this fourth here, that's going to demonstrate and show that I have 7/12. But remember, you're subtracting. So what that means, you're taking 1/4 and subtracting from the 1/3. Okay, so now let's take a look here. If I were to do that, I want to figure out how many 12ths would be equivalent to this. So let me put my 12ths here. So 1/3 is equivalent to 4/12. And 1/4, I'll move this over here for a second. 1/4 is equivalent to, you kind of put it here so it's a little bit more even. I bring you up here. Okay, 1/4 is equivalent to, oh, you get up here, 3/12, right? So if I have 1/3, and now I know I'm working with 12ths, and 1/4 is equivalent to 3/12, so that would be 3 of these guys. If I want to take 3 away, 1, 2, 3, that leaves me with 1/12. So let's notice how it's a little bit different because now you're subtracting, but we still wanted to find out finding a common denominator. So let's go back here. So with subtracting, you find the common denominator, and then you subtract the first one, 1/3, which equals 4/12, and you subtract 3/12, and you end up getting 1/12. Now, remember when I stated that I do not like multiplying both denominators? Here's my reasoning why. It does work, but let's say you have two denominators, such as 5 and 10. If you multiply 5 times 10, you're going to get 50, and therefore your denominators will become 50. But then if you have 50, you're going to more than likely end up having to simplify all the way back down. So you're going to end up doing more work. So instead of changing both fractions with a denominator of 50, you could easily just change one fraction that has the 5, because the one that they would, the first thing that they would have in common between 5 and 10 is 10. So you don't really need to multiply 5 times 10 to have 50. You could just find a common denominator by listing your multiples and finding the first one that they have in common. It's a little bit easier and it's a little less work than having to simplify. So that is my reasoning. Again, the reason why I would not want to multiply the two denominators together to get one common denominator, you may end up having a really large number, of which then you might have to simplify all the way back down, which is more work. So if you just list your multiples and find the first one that they have in common, to me, you're off to a better start. All right. Hopefully you liked this video. Again, hit that like button. Hopefully you got something out of it. And my next video you will see, we're going to continue practicing a little bit, but with a little bit different of fractions, okay, with adding and subtracting. All right. I hope you take care. Thanks for watching.